All right, hello and welcome. We are looking at the second part of Chapter 7, that would be 7.2, where we are applying exponent properties that involve quotients, right? And if you don't recognize that word quotients, remember quotient means division, right? The answer to a division problem. So in this particular video set of videos, we're going to be able to use the quotient powers property to divide variables. We're also going to be using a property called the power of the quotient property to divide variables with powers. So let's jump into it and talk a little bit about what we know about quotients. So first of all, a quotient is a division problem. So we can all do a simple division problem like this, right? Like 7 divided by 7. Excuse me. How many times does 7 go into the number 7? The answer to that is, of course, 1, right? And so it doesn't matter which number we use. Whenever we divide a number by itself, it always equals 1. It can be 1,000,002, and we divide 1,000,002 by itself, and we end up with 1. Okay? Now, this follows that if we were to divide a variable by itself, that would also equal 1. Because if x is any number, if it's divided by itself, it's going to equal 1. So it doesn't matter what variable we're dividing by itself, it will always equal 1. Now, we can extend that a little bit and say, all right, well, what if we're dividing a number that is a power of something else? For example, 49 over 7 is the same thing as 7 squared over 7, right? Well, what is 49 divided by 7? We know that it's 7. So notice what happens here is we've essentially canceled out one of these 7s, right? There were 2 7s on top multiplying each other and 1 7 on the bottom multiplying each other. And we said a 7 divided by a 7 makes 1. Oops. So it cancels out. And I'm left with just a 7 up there. Let's do the same thing with maybe some larger powers of 2. What if we were to do 2 to the 5th power divided by 2 squared? Now, in actual numbers, to simplify these, I should say, because these are actual numbers still. To simplify these, right, 2 to the 5th power is 2 times 2 times 2 times 2. So that's 4, 8, 16. This is 32 divided by 4. Well, what's 32 divided by 4? How many times does 4 go into 32? That would be 8. But 8 is a power of 2. That would be 2 cubed. So what happened, right? We had a bunch of 2's, 5 2's being multiplied together in the numerator, and we had 3 2's being multiplied in the denominator. Excuse me, 2 2's being multiplied in the denominator. So what happened here, right? The answer we came up with was 8, or 2 cubed. In other words, the 2 2's in the denominator canceled out 2 2's in the numerator, and we ended up with 3 2's being multiplied in the numerator. In other words, we had 2 cubed. So notice how that when we're dealing with bases that are the same, right, 7 and 7, 2 and 2, we can essentially, if we write it all out, cancel out those like bases from numerator to denominator. Well, this kind of leads to a rule that can help us do this very quickly without having to do this actual cancellation. And I wonder if you've seen it already, right? This is 7 squared over 7 to the 1st, and that answer ended up being 7 to the 1st. This was 2 to the 5th divided by 2 squared, and the answer ended up being 2 cubed. If you've noticed that 7 squared divided by 7 to the 1 is like 7 to the 2 minus 1, you can see that this subtraction that is happening leads us to the correct answers. And it turns out that that always works, and that's a general rule for division that works. If you have like bases, a to the m over a to the n, the division of these two variables is a to the m minus n. In other words, if we're dividing variables, we subtract the exponents. Let's go ahead and do a couple of examples. 8 to the 10th divided by 8 to the 4th. I'm going to use this rule that when I divide variables, I subtract the exponents. So this is 8 to the 10 minus 4, which is 8 to the 6th power. And just like in the last section, we're gonna say it's okay for now to leave these big ones as their exponent form, right? This is an exponent. This is an exponent form. My pen has a button like right next to where you write, and I constantly press it on accident and go to the next slide. I apologize. We can write these in exponent form, and that's okay. Okay, let's keep going. This is negative 3 divided negative 3 to the 9th divided by negative 3 to the 3rd. That's a 3. It looks funny, but it's a 3. The bases are the same, so this is negative 3 to the 9 minus 3, or negative 3 to the 6th. In C, we have a combination of things. Notice that we've got some multiplication happening on top. We need to do that first. So we have to do a little simplifying. Now, this is going to take us to the rule that we learned in the last section, that when we multiply any sort of variable, that's an a, to the m times a to the n, we add the two things. So we're going to combine the two rules here. The first thing we're going to do is multiply these together. So that's 5 to the 4 plus 8, which is going to be 5 to the 12th over 5 to the 7th. And now we'll do the division because we've done that. So this is 5 to the 12 minus 7, or 5 to the 5th. And finally, in our last example here, notice that we're multiplying these two things together. Now, remember, this is a fraction. The 1 over x to the 4th, that's in the denominator. And when we multiply fractions, we multiply numerators and denominators. This x to the 6th is a number, which means it's divided by 1. We can always rewrite a number and divide it by 1. So this is 1 times x to the 6th over x to the 4th times 1, which is really x to the 6th over x to the 4th. And if we continue with our rule here, this is x to the 6th minus 4, or x squared. And that concludes our first video. There are some questions back on your notes and your Canvas lesson that I would like you to do, and we'll go over those first thing in the next video. So go do those right now. Thank you.